Spatial computing, it's the technology which powers the blending of the virtual world and the physical world. AR, VR, 3D models, digital twins, IoT, AI/ML. We believe that AWS is the best place to build spatial experiences. Our goal is to help our customers bring their big ideas to life.
To be the asset repository for really any kind of 3D content. You're capturing a lot of data, and what do you do with that data after you capture it? That's a lot of labor, right? We get the final result, and it's a guy sitting there scrubbing, filling in holes, like what do I do with it then? We wanted to reduce the amount of manual cleanup that has to happen in these kind of photogrammetry pipelines. Can't we automate those kind of things? And we essentially have saved hours of time of someone manually cleaning up those individual pieces. And so you can upload your LAS or E57 file, and then you can actually visualize that data just straight in a web browser. This is key for people that have, terabytes of data in a file format. I don't want to necessarily download that just to open it and have it be the wrong thing. So we're uploading the content here, so it's automatically uploading it, it's automatically parsing it. You don't have to do any of that work. It's surprising how fast it will process in some of these containers.
Please welcome Heidi Buck and Jeff Fisher.
Hey everybody. So I am here with Jeff Fisher. We are from AWS. We are going to tag team this talk, and we're going to talk about, at AWS, a group that we're in called the Spatial Computing Group, an emerging tech group. And we're also going to talk to you about reality capture, and we're going to end it with a couple of cool prototypes that we've built on AWS relating to reality capture. And then we've got our little friend backstage, Spot, is going to come out for a minute, and we're going to talk about a demo that we've got going around here. So let me move on. There we go. So you all met me in the earlier panel this morning. My name's Heidi Buck. I've been at AWS for a little over a year now. And I come from 20 years as a Navy civilian at a Navy research lab in San Diego, where I ran innovation groups, prototyping teams, specifically 2 different teams over the 20 years. So the first half, for the first 10 years, I was doing computer vision, automatic target recognition technologies, and satellite imagery, and drone video imagery. And then the second half of my career there, I was doing spatial computing. I ran an AR/VR lab for the Navy. So spatial computing, I was going to ask, this is a rhetorical question, but can anyone define spatial computing? It's kind of a new-ish term, and its definition doesn't easily roll off the tongue. So when I came to AWS, one of the first things I did was I created a little video snippet for what spatial computing means to AWS, and so we are going to play it here. And I hope we have sound for this.
From rocketry to space travel, from the home computer to the World Wide Web, to smartphones connected by satellites, revolutionary technologies have brought people together to communicate like never before. Technology has opened the door for new levels of understanding. Spatial computing seamlessly blends the virtual and physical, enhancing how we visualize, simulate, and interact, immersing 3D data with location. With spatial computing, we are connecting our virtual and physical worlds, because now, more than ever, there is a need to connect in new and meaningful ways. AWS is a company of builders, innovating and inventing on behalf of our customers. We are developing the building blocks that empower our customers to build, deliver, and manage spatial experiences. So, let's invent the future together.
So what is spatial computing? We said it's the technology which powers the blending of the virtual world and the physical world, and it enhances how we interact with data, how we visualize data, how we simulate with data. And specifically, that data is 3D data and location. And so there's all sorts of technology that comes underneath or feeds into spatial computing. The tech that I worked on in the Navy, AR, VR, 3D models, digital twins, IoT, AI/ML, and then kind of newer tech today, Gen AI as well, generative AI. So one of the things we did is we tried to list all of the technology that encompasses spatial computing. And so we built the spatial computing spectrum. On the left-hand side, we have technology that resides more in the virtual world, more on the cloud. So think tools, think software. So CAD tools, simulation tools. On the right-hand side, we've got tech that lives more on the physical edge, so physical tech, so think robots, they're physical. Digital twin is listed here because you need to think of the digital twin as an object, all that data as an object, and it's this object which represents the physical world, that physical smart factory. But all of this tech feeds in to the metaverse, and the metaverse was the buzzword recently until Gen AI came along, right? So metaverse was the big buzzword. So we were trying to explain how spatial computing fed into the metaverse. And now you can argue about all of this technology and whether it should be a little more to the left or a little more to the right, or, oh, you forgot this tech, or you shouldn't have that tech. But what we were attempting to do is describe spatial computing as a spectrum here. So my team at AWS, we believe that AWS is the best place to build spatial experiences. And so we came up with these 4 pillars for spatial computing enablement at AWS. So the first one we have is infrastructure. So AWS has the widest and deepest set of building blocks. So when I say building blocks, think services, think compute power for enabling those spatial experiences. Also, we strive to reduce costs for our customers, increase efficiencies for our customers, all by promoting open standards, open interfaces, and being device agnostic. People is kind of obvious. There are a gazillion people at AWS. They're super smart. They work in all sorts of different tech domains, lots of different experience and different technologies. And then we have a broad ecosystem of both partner tools and AWS tools, which allow our customers to have a choice in which direction they want to go. So speaking of partners, here is a list of some of our spatial computing AWS partners. Now, I do have to apologize. Unveils is here, and they are also a partner, and they do not appear on this list, so I apologize. They recently became a partner, and this list was built before they became a partner. So I've linked you back to the partner page, QR code there as well. The idea being is these are the folks that you can go to when you want to partner with a third party to build something on AWS, a spatial solution on AWS. So my team at AWS is called PACE. We are part of PACE, which is prototyping and cloud engineering. So we empower our customers to innovate faster, think bigger. Our goal is to help our customers bring their big ideas to life. And we've been doing that since 2018 with way over 200 prototypes by now. So PACE is a prototyping team. It's a global team. So anywhere in the world, there is a customer. If they have a prototyping need, there is a team there to assist them. However, my team is tech-aligned, and so we are technology-aligned to spatial computing and emerging tech. And so we're a little bit different. Oh, and we service North America and South America, so that's what Jeff and I represent today. And then I have a few more people here as well. So I keep saying prototype. So what do we define as a prototype? So a prototype is more than a proof of concept, less than a pilot. So we typically say it's like 6 to 8 weeks of build time. Now, there's a couple weeks in the front for qualification, there's a couple weeks in the back for security and closeout and reporting, but think along that time frame. And so as a prototyping team, we can either build with our customers or we can build for our customers. Works either way. So we are a no-cost resource. We invest in our customers by providing prototyping experts and AWS services at no cost during the prototyping engagement. Obviously, there are a lot of customers with prototyping needs. There are only so many prototyping teams. So, what I encourage you to do is, if you're an AWS customer and interested in a proof of concept or a prototype or even a production-ready system, Work with your account manager because they can tell you about all the different programs at AWS to help you in wherever you are in your cloud journey. And so this is my last slide before I hand it over to Jeff. And so what I wanted to say here is, if you're interested in learning more about spatial computing at AWS, we have a blog. That QR code takes you to that blog. Jeff and I run the spatial computing blog. We often put partner blog posts on there, so if you're a partner and interested in writing a blog post that we can publish, please let us know. We write our own blogs as well, so I encourage you to take a look at it. But again, what I want to leave you with is talk to your account manager. There are all sorts of solutions for working on AWS and getting you started with spatial computing or reality capture on AWS. And I'm going to hand it over to Jeff.
Thank you. Click the button. So I'm going to go through a little introduction of myself here in a minute, but I wanted to first start with this slide here. And this is from our CTO of Amazon, really talking about how 3D will be as pervasive as video. And I would kind of argue against that with the community here in this room, that we believe that it is as pervasive today, right? That it is driving innovation, is driving business. But it's important to understand that it's getting to the point, this evolution, that CTOs are saying it in a broad stage format here, right? That it's not just a handful of people on an innovation team having this idea, that it's actually having impact at a much larger scale. So, interesting concept here. A little bit about myself. As Heidi was saying, I'm a technical program manager on the PACE spatial computing team. I've been at AWS for a little over a year now, about a year and a half. And previously, I spent 10 years at the National Institute for Aviation Research in Wichita, Kansas. If everyone's been there, then great, but if not, a lot of aviation, a lot of aerospace, and some defense, but really focused on 3D for the entirety of that career. And looking at how 3D, how simulation plays into the aviation ecosystem. And started out a lot on the CAD side. My first job was actually doing 3D design. And the interesting thing is when I joined AWS, I was just like many people getting into the cloud experiences, I was a little lost on how cloud applies into these kind of workloads and really how to actually execute something, how to do it. So there was a healthy education period to go through and do that. So I wanted to give you a little introduction to go through and start connecting some dots so it's not as foreign of a concept if you get into it. And I wanted to apply it a little bit to some of the reality capture pipeline concepts and to kind of show some examples here in a minute. When I get past this, I'll show you a couple use cases that we built as a prototype. And so I broke it up into 3 different areas here, and I listed just some icons here of the different services that would apply. Note that the colors actually mean something on the services themselves. Green being storage, so think about cloud storage. That orange being compute, so processing is a big aspect there, and purple being networking is kind of the color code there. And so we look at the beginning pieces of this. We have the capturing process, and we're really talking about people in the field doing capturing tasks, whether that's terrestrial LiDAR, whether that's drone-based. You're capturing a lot of data, and what do you do with that data after you capture it, right? And of course, we're basing the assumption that we're going towards the cloud in these kind of workloads. So how do I get terabytes of data that I captured here in this field, and how do I get it into some of our cloud pipelines? And today, many people take hard drives, they take it back to their office, and they wait for all that stuff to upload. And hopefully you have healthy upload speeds, but many of us don't. So looking at some of these other things as options to do that, Snowball would be a good solution for this. This is essentially a ruggedized PC that you can dump that data on, and you literally can physically ship it back, or there's also some that are 5G connected to do some of that data transfer. So it's a little bit easier to do. Wavelength, this is a good use case when we start to see some of the laptops in the field not be able to actually run some of the 3D applications with how much data we're pumping into it. These are virtual machines or instances that are at the edge, at the 5G telco centers. So you get much better latency and much better performance, and you can essentially spin up a VM to be able to do what you need to do in that moment. So a lot of better performance. And then when you're looking at job sites and connectivity and networking, there are private 5G connections that can be set up at the site, so you can go through and do those kind of data transfers that way. Going into some of the processing, I'll show you an example of a processing use case here in a minute, but a lot of it is just straight compute, and there's a few different flavors of that. You can use straight instances or VMs. We call them EC2s. That's kind of the Amazon branding there. And you can also do containers. These are kind of sliced up versions of EC2s, but you can just consume pieces of it. And the idea is that you can not have to manage this kind of infrastructure. You can just consume it as a user. So a lot easier from a end user perspective. And then we look at storage, and this is where content, as we start capturing all this content, and we're like, what are we going to do with all this? And if you've ever had an IT department yell at you for keeping a bunch of data on the network, and you're like running out of storage, and it's not being backed up, these are kind of solutions geared towards storage as a solution there. So simple storage service or Amazon S3, that's kind of our object storage format. It's essentially throw your file up there and it's stored. There's a bunch of different ways to do it, and it's obviously backed up 3 times, I think, in a availability zone. But we start looking at different versions of that. You have file system style storage, like your normal, save it to a network folder. That's Amazon EBS. But then we looked at kind of orchestrated services of this, or orchestrated frameworks, which we call the Amazon Visual Asset Management System, or VAMS, which is an open source solution that we pushed out about a year ago to be the asset repository for really any kind of 3D content, right? And it's built on the AWS framework, so we can ensure that it's done appropriately and also in a scalable way. So I'll show you an example of that here in a minute as well. So let's look at a use case. This is a prototype that we did. We finished it up early this year with a construction company, KCI, if you're familiar with them. But it's essentially a photogrammetry pipeline that we built on AWS from end to end, with the idea being that we wanted to control the process, right? We want to be able to consume an off-the-shelf photogrammetry solution, but basically run it all in a private environment. So we'll show you a little hype video, I would say, of this. It's a little quick. But we're taking that, and it's essentially managing this from end to end. So we have kind of a job orchestration here. You can go through and build it, create your new job. We can link, again, to the S3 bucket of photographs. You'll go through and run it. And we actually have a different stage tier here, and I'll go through some of this here in a minute. But you can really build this recipe and run it on an as-needed basis. And you ultimately get your 3D content in the end. Now, the nice thing about this, when we start building these kind of custom pipelines with these tools, is we can start building out specific pieces of this that are important to your specific business process. So in this case, we wanted to reduce the amount of manual cleanup that has to happen in these kind of photogrammetry pipelines, right? Where you capture these big areas, they're in construction, so they're trying to go through and clean up things like trees and rocks, and in this case, cars is what we picked out here. But that's a lot of labor, right? We get the final result, and it's a guy sitting there scrubbing, filling in holes. Like, what do I do with it then? Can we automate those kind of things, right? And the nice thing about this is we can run it through an image processing sequence that we have at AWS called Amazon Recognition. It goes and builds that image mask on the right. So you see those black squares on the lower right-hand corner. That's essentially where the cars are in the actual image. It pairs those together in the pipeline and feeds that into the system. And in the end, we get a resulting model without any cars, right? Now, image recognition stuff like this runs in the blink of an eye. It doesn't take any processing at all. We've already built the frameworks to recognize cars. We just have to build some code to go through and say, hey, draw all these boxes where the cars are supposed to be and feed that in. And we essentially have saved hours of time of someone manually cleaning up those individual pieces. Now, we chose cars in this case because that's what we needed as a prototype proof of concept. But it could be anything else in this kind of image. We just have to identify it and mask it out. Now, of course, once you build it, what can you do with it? Of course, you kind of kick off your engineering workload as well. You can throw it into your Revits and Civil 3Ds of the world. But what can you do as well from a AWS perspective, and we have a solution called TwinMaker, which is really a 3D environment in the cloud. We can go in and dump these models into it, and then we can also start attaching in IoT sensor data. Right? So we start feeding this in, and we can give contextual information to that sensor. We can tell you where it's at, we can tell you what sensors it's reading, and we can kind of give you some perspective of what's going on here. This is kind of the connected building concept here, just in a scalable fashion. So let's talk about asset management. So this is like I said, an open source solution. You can go to GitHub today. There's a link for it. You can look at all the architecture for that, and actually has some deployment scripts. You can go and deploy it straight into an account today. But the idea here is we all have 3D assets. We have them a lot in engineering use cases, but what do I do with it afterwards? I don't want to necessarily just leave them where they're at. I want to put them in a central location. I want to be able to apply analytics of that. I want to be able to share them. I want to be able to process them a certain way. How do I do that today? So in this case, VAMS is kind of our answer to that. And the interesting thing about VAMS is it kind of grew out of a prototyping style use case where we went through years of this struggle, and we said, hey, let's actually build something so we can make this a little bit more consistent. And then just about a month ago, we released an update here that supports LiDAR use cases. And so you can upload your LAS or E57 file. It will go through and process it to be in a lightweight format for the web. It actually just builds an octree that is needed to stream it in. And then you can actually visualize that data just straight in a web browser. This is key for people that have terabytes of data in a file format. I don't want to necessarily download that just to open it and have it be the wrong thing. Or if I just need to spin it around to get some information on it, I'd like to be able to do that in just a quick format. This is a good way of doing that today. And we actually built it off of an open source viewer, so you get all the inherent performance benefits and measuring capabilities that's in that. So nice little tool there. We have a little bit of a, oops. We'll go here. So this is a little bit of a hype video showing that out. My hype video would show. I get interrupted by the dog. Well, we'll play it at the same time. There we go. Which one will you look at? Thanks. So we're uploading the content here, so it's automatically uploading it, it's automatically parsing it. You don't have to do any of that work. It's surprising how fast it will process in some of these containers. This large, multi-gigabyte file processed in like 10 seconds, so it's pretty quick. And then I can just view that all straight in a web browser. You'll see that kind of rezzing up effect that's happening, of course, because we're not streaming in every single pixel. You have to get to that location for it to do that. And then we'll wrap it up. So, and with that, I can leave you with the last little thing. So we brought our robot dog here to kind of talk about some of the different capture processes and IoT pieces. Kamate's out there with a demonstration that's actually using a Magic Leap headset to program and orchestrate where that device is at in the space. A little bit different concept than necessarily using a tablet or doing traditional programming. So it's a good way to see kind of the blend of the technology, right, between AR and robotics. And that's it.
That's it.
If you do care to give us any feedback or to reach out to us, there is a QR code to connect. So,
Thank you.